So, hello, we've opened the webinar. People who have attended PalmSens webinars might know my colleague Adi already, who is looking at the chat and the Q&A and will be your voice during this webinar. And he is supported today by Sabine Cassette, who is from Linxens and who will then focus, let's say, more on the questions that will be answered by Kathleen. So Kathleen Ramzami is here with us. She is an expert from Linxens for electrode production, and she will also be the person who gives the major part of the talk. I will just give a quick introduction when we start about, like, say, common electrode production materials. And in case you don't know me, my name is Lutz Stratmann. I'm an electrochemist at PalmSens. I'm doing a bit the warm-upper for Kathleen today. Okay, so the poll is closed. Let's look a bit at the results. I'm quite curious. So yeah, so many people use screen printed electrodes, and a couple of people have used PCB electrodes. So maybe you guys are just here for knowing exactly how these are made. And other people work with thin films or even other electrodes. And I see it looks to me like by far the biggest problem of these type, or the biggest challenge of these type of electrodes, is reproducibility. Yeah, I have observed that with customers, especially for impedance spectroscopy, which is very interface sensitive. So again, welcome to this webinar held by Linxens and PalmSens together to, well, talk to you about roll-to-roll manufacturing and how it can help you with your electrochemistry. Okay, great. I will just give a quick introduction to, well, first, let's see that yes. Okay. So first to disposable electrodes. Okay. Why do we want disposable electrodes? What are disposable electrodes? Well, you most likely have seen somebody who uses a glucose meter to define how much glucose is in their blood. This is used regularly by diabetes patients, and they use these type of disposable electrodes. Here in the picture, you see another example where we measure painkillers in blood. This is done by the Finnish company Fipot. And they have these electrodes that are so low cost that you can just throw away the electrode. So you don't need to do reusing. Usually this is also connected to high volume production. And now some people might say, like, isn't sustainability important these days? Why do we make electrodes that we can just throw away? Well, this is very important. So the preparation of the electrode can be done by an expert, but using them is then done by somebody who's non-lab educated. So we give electrochemistry to everybody. Everybody can use it. And afterwards, you throw the electrode away. A reusable electrode would have to be in some way be prepared by an expert again. But this way, we can just have the preparation by the expert and then using the electrode by anyone. There are many different application examples for this. So you find them, well, the examples that we just used, in vitro diagnostics. You can also look for biomarkers, for sepsis markers, etc. So this is where you find them. You also find them for food safety or quality evaluations, looking for pesticides on food, or maybe how much sugar is in a certain type of food, like in a potato, to determine what's going to happen with that. Is this going to be crisps? Is this going to be sold as a cooking potato, etc.? Or looking at water quality, looking again for pesticides, heavy metals, or maybe nitrate in your water. And this is where you find these type of electrodes. And I think there are two well-established types of disposable electrodes on the market. One of them are the ones that are made with screen printing. So we have for screen printing usually some kind of mask, which is like a net, and the net has like open parts where you want later ink to be on your substrate. The substrate can be, well, different things. Common is ceramics or maybe some type of polymer like polyester. You usually take this mask and you fix it in a hovering state above your substrate so it isn't touching it. Then you fill the mask with ink, and that ink is usually some kind of like mixture of an organic solvent, a conducting material like carbon particles, gold particles, and then this also includes a polymer binder. Okay, so you fill your mask with the ink, and then you use a squeegee, which is like a little rubber well, a little rubber pressure thing like you use in your bathroom maybe to remove water from windows. And you just press it across that screen so that the mask firmly but shortly touches your substrate. And at the points where paint can go through the mask, you will leave the paint behind at the substrate. Then you cure it, so you warm it up to remove the organic solvent, and you end up with a matrix of polymer binder and conducting particles like in this type of blob on your electrode, and that is now forming this, well, conducting, well, in this case, carbon-based species. And these ones are usually like in the thickness range of like 25 micrometers or maybe up to 100 micrometers. So they're rather thick compared to thin film electrodes, which are usually made by vapor deposition. So here often we have a mask again and a substrate, but the mask now has parts that are opaque and parts that are transparent. And the transparent parts now represent the parts where we want to have our electrodes in the end. So here we put a photoresist on the substrate, then we put the mask on top of the photoresist, and then we illuminate the whole thing, maybe with UV light or other certain frequencies. The photoresist will change at the parts that have been exposed to light, and then we use a washing solution to remove these changed parts. Now we have this, well, now we have basically our mask on our substrate, and we expose now this mask to a metal vapor. We can do this, for example, by putting the substrate and a metal source into a vacuum, and then we're heating up that metal source. A popular way of doing it is like sputtering. So we're shooting ions or other particles at the gold so that it starts to heat up and go into the, into a gaseous form, and then because the substrate is colder, it deposits on the substrate. It deposits on all the parts, but then we are washing away with a different washing solution the remaining photoresist, and only where, in this case, for example, our gold has been deposited directly on the substrate, it sticks to the places where we want it to be. The result of that is a very thin film. Here we're talking like around 150, 200 nanometers. And this is pure metal. So this is a very different type of electrode. And these are two very well-known ways of doing it. Here as an example is the company Microx. I've chosen them because they actually offer both of these products. So you can see like from the same producer how different it looks. So recently, a new type of electrode has entered the market, and Linxens is one of the experts and producers for these types of electrodes. And I will just now give the floor to Kathleen, who will tell you all about it.
Thank you, Lutz, for this good introduction of the technology available onto the market. As you see, screen printing and sputtering is the main available technology. So before to explore how R2R manufacturing can provide reproducible PCB-based electrodes, I think the good point is to revisit the basic of the biosensor system to understand where Linxens offer is. In the system of biosensors, you have an analyte. This analyte reacts with a bioreceptor, and this bioreceptor reacts with a transducer, and this transducer will transfer an electrical signal to an electrical device. This electrical device can be a potentiostat, like those from PalmSens, and Linxens will provide the transducer. So our transducer in general will be in gold. This transducer will be manufactured in R2R, and the advantage of this process is the fact that the transducer will be sensitive, reproducible, robust, and the R2R manufacturing process is a cost-effective process. And I will try to convince you about that by presenting you all the process. But first of all, let me show you which kind of biosensor transducer we develop. So we have biosensor transducer by strip. So in general, it is an electrochemical sensors. You have for example, a usage like point-of-care testing. And we have the biosensor transducer stick onto the skin. So it is a patch. And in general, the usage you can have is for vital sign monitoring like EEG, ECG, or CGM. So for this webinar, I will focus my presentation on the biosensor transducer by strip, but maybe another time we will have the opportunity to see what a biosensor transducer stick onto the skin is about the manufacturing process. So let's see for the strip version, what is the manufacturing process. So we start the manufacturing with the lamination of a copper foil onto a flexible substrate. On this copper foil, we will laminate a photosensitive film. And after that, we will send a UV light, on a selective area to print the design that the customer wants. For example, if the customer wants to have a circle or a square, the UV light will come at the surface of the photosensitive film to print this pattern. After that, the area where the photosensitive light will not print will be dissolved. And as you can see on this picture, you will have an area where the copper will be protected by the photosensitive film and an area where the copper will not be protected. So this film will cross a chemical bath, and the area where the copper is not protected will be chemically etched. After that, we will remove the photosensitive film and we will have a metal electrodeposition. And this metal electrodeposition will depend to the customer demand. So in general, we have gold as a finishing, but we can have a platinum, palladium. We have different kind of electrodepositions that we can provide for our customer. And we have some options. So if, for example, you want to have a coverlay with a specific property, we have the possibility to laminate this coverlay around the electrodes. We can also change the packaging size of the electrodes. So initially, you start with a system where the diameter of the electrode is 15 centimeters, but we have the possibility to slice the electrodes and obtain something shorter. And in general, the diameter is around 35 millimeter. We have also the options to do the pre-sangulation, we call it. It's just a system where you can facilitate the sampling of your electrodes during the usage. So this is the roll-to-roll manufacturing process that we apply, that we use that we process for the electrode manufacturing by strip. So with this system, we can obtain different constructions. So we can have a single side, double side, well system. So it will depend to the demand from our customer. We have also, thanks to the photolithographic system and the etching of the copper, you can obtain different shape. And we have a limitation on the design. We cannot go down to 50 micrometer in resolution. And we work with different materials. So in function of your need, in function of your specification, we can use different material. The only constraint is the fact that we need to have a flexible substrate. So we are not working on rigid substrate. So what makes our electrodes highly reproducible? So the first thing is, as you see, our process is in roll-to-roll. So it's a continuous process. And thanks to this process, we eliminate any batch-to-batch variation. So for example, in screen printing, you work on sheet. And sometimes when you start with the first sheet, you use another sheet. The viscosity and the rheology and the property of the ink change during the time. And this is what we don't have with our roll-to-roll process, because one will see the same process on the same time. The other advantage is on the photolithographic process. because thanks to this process, you can obtain a robust design, and this process induces a low variation on the design resolutions. And the last point and the last argument I have is on our quality of our metal, because it is a pure metal deposition. So if you compare with the screen printing, in a metal ink, you have a resin, you have some solvent, and all these components will impact the final conductivity of your electrodes, of the conductivity of your transducer. So thanks to our electrode deposition, you will have a pure metal deposition. So the conductivity of your electrode at the end will be better in comparison to a screen printing system. So let me try to convince you with some data. And we evaluate the performance of our electrodes with the CSCM Institute. And we start by comparing the performance of our electrode without any cleaning. And we try to evaluate the reproducibility, and we compare it with different technology available onto the market. And as you can see, our electrode present a good reproducibility. So we continue this analysis, this electrode performance evaluations. We try to see if the cleaning impacts the quality of the performance of our electrodes. So we study the oxido reduction separation potential. And just for your information, in general, a good reversible system presents oxido reduction separation potential around 59 millivolts. In our case, with and without cleaning, we have oxido reduction separation potential around 100 millivolts. That is quite good for a disposable gold electrode. And as you can see, if you compare our performance with the other technology available onto the market, our reproducibility and the purposes that we can present is quite good. So as you can see with the last results that I show, our electrode is user-friendly because you can use our electrode with a cleaning process, but you can use it without cleaning. Thanks to our R2R manufacturing process, thanks to our photolithographic process, you have the possibility to customize your design, to customize the choice of your material. The only constraint is on the fact that you need to have a flexible substrate. We have some option to rigidify the electrode at the end, but during the manufacturing process, we need to be flexible. And as I present during my presentation, we have the possibility to do biosensor transducer stick to the skin. And you can imagine if you merge the wearable potentiostat from PalmSens with our stick to skin wearable biosensor transducer, you can imagine that you can have different opportunity to create new application, new biosensor application with this combination of this both technology. Thank you.
All right, thank you very much, Kathleen, for your presentation. Meanwhile, there are already some questions in the Q&A, and it's a good reminder for everyone that if you'd like to answer or ask a question, you can type these questions in Zoom on the bottom at the Q&A section. And the first question, Kathleen, is for you, and it's about what's the minimum width of an electrode by this method, if you reuse this method?
So the minimal resolution that we have is 50 micrometer. It's our limitation. We already tried some less diameter, like 30. But to ensure a good quality on the design, we prefer to stay on 50 micrometer.
All right, that's very clear. And that's a good tip, by the way, for all the participants. If you see there, you can see the questions that other people ask in the Q&A. If you like a question, you can upvote it. So maybe you're like, yeah, I want to know this answer first, then please upvote them. Next one, Kathleen, is also for you. What was your cleaning process when you compare all the electrode technology, when you compare them?
Yeah, I can share again my screen, but the cleaning process was in sulfuric acid, and we apply a cyclic. Yes, so you can see the cleaning procedure is described on the slide. So we use a sulfuric acid media, and we apply a CV from 1.5 volts, 20 circle with a speed of 100 millivolt per second.
All right, very nice. Is it also possible to get other type of reference electrodes, like for example, silver chloride instead of gold?
So it is a project where we start to work. Today, our reference electrode is in gold, but we feel the market need to have a silver chloride reference electrode. So this is why our R&D team is working to find the good reference, because we will never achieve to have a reference electrode similar to what we have onto the lab. So we will have a pseudo reference electrodes. So we need to identify the good ink, the good silver chloride ink, but it is something that our R&D team is starting to work.
All right, and are graphite or graphene services also possible?
We can imagine to have a graphene over our copper, but we know that graphene in general is deposited by a CVD, or I don't know, a special technique. But if the graphene is, you have a solution in ink, we can maybe think to have a dispense operation to drop the graphene ink over our electrodes. But it is not something that today we can we provide in our site.
Okay, thank you. And then a question we get quite often about organic solvents. So is the flexible substrate and coverlay, is it resistant to organic solvents? Like for example, ethanol or...
So our standard electrode without coverlay resists to any solvent. I will not say any because you always have some solvent. Maybe if you let this solvent during 80 minutes or I don't know 1 hour, I can be sure that it will resist. But from the feedback from our customer, we know that our electrode without coverlay resists to standard solvent like ethanol, acetone. But if we apply the coverlay, the adhesive of the coverlay will react with the solvent. So we need to discuss with the customer to see what is the best time exposure to apply for this usage.
Right. And this is actually two questions in one about the thickness. One is, can you tell us what the thickness of the laminated copper foil is? And the second one is, have you also measured the thickness of the electrode deposited gold?
So about the thickness, we have different material available. It will depend on the request from the customer. In general, we have for strip. We work with a polyimide thickness around 50 micron, with a copper around 80 micron. But it will depend because we work with different substrate. So it will depend on the application of the customer. We can adapt the thickness in function. And the second question is on how we measure the thickness of the gold. This is the question?
Yes, so the question was if you've measured the actual thickness.
Yes, we have specific device, optical device, where we are able to measure the thickness of the gold. And it is one of requirements that we have for our quality team. All product that we produce is monitored on the thickness. We have a dedicated technique to measure the thickness during the manufacturing process.
Then we have a question about defects. So the question is, PCB technology-based electrodes, they suffer from defects in the metallic layer, like copper or nickel, exposed through the pinholes in gold. So what makes the Linxens technology better at providing pinhole-free gold services?
This question, I think, is maybe on our process of electrode deposition, because we have a specific electrode deposition technique that we apply on our roll-to-roll system. So there is a lot of, for PCB manufacturing, you have the annealing technique where you don't need a contact it's an electroless deposition. We don't use electroless deposition, so we use a specific technique where the raw tool electrodes is in contact with an electrodes to provide the current. And I think thanks to this technique, we are able to produce a deposition of gold with a good density, and thanks to that, you don't have this pin. But we have some limitation on the usage of our electrodes. We cannot go up to 1 volt in a chlorine media because, as you said, we can have the risk where sometimes, if there is some copper, this copper can react with our electrodes.
Then the next one is actually 2 questions combined. So I'll start with the first one. So you mentioned that you're using nickel as a barrier for the copper migration into the gold. But the question isn't nickel an ignoble metal as well? So how will that work?
Is the nickel a noble metal also?
Mm-hmm.
For healthcare application, in general, we have gold as finishing, or silver sometimes, platinum sometimes too, but nickel not, because nickel can passivate easily, and the passivation of the nickel can induce a less good conductivity. So in general, we don't have a request from our customer to use nickel as a final layer. It's just an intermediate layer to isolate the copper to the system.
Exactly. And when nickel is being used as this intermediate layer, can it become accessible if you bend the Linxens electrode? Would you be able to see it?
No, you can't, because at the end, the electrode deposition of the gold will be done on all the surface of all the conductive surface that you will have. The gold will be deposited, so you will not have you can see it.
Mm. And so when it's under stress, you don't have like cracks or something in the gold layer that would expose the beneath lying metals.
No. Because for the story, Linxens come from the manufacturing of microconnector for credit cards in the past. So we well know the constraint on the flexibility, and our technology is compatible for any mechanical constraint. And we are creative to create something where whatever the deformation that you will apply, the metal will stick, and the gold will keep the properties that he have.
All right, very good. Then I have a question for you, Lutz. This is one you get more often. Will this webinar be recorded?
Yes, this webinar will be recorded, or it is recorded right now. And as far as I know, you will all get a link so you can rewatch it. That's maybe also a relief for all your colleagues who couldn't make it. So you can send them a link and they can watch this webinar back. Or if maybe one of us has talked maybe a bit too fast, so you can watch it again.
Well, that's very good. And then there is one question I would like to split, one for you and Lutz, and one for Kathleen. But let's start with you, Lutz. What's the minimum order quantity? That's for the standard electrodes.
Right, that is 100 pieces. So they're delivered in reels, so in these wheel-like reels that Kathleen has also shown. And the minimum order quantity at PalmSens is 100 pieces. And I guess if you want to have a batch of custom electrodes, then it's best to contact Linxens directly, because, well, you will have to have a proper exchange and it needs to be very clearly communicated what you want. But I expect the minimum order quantity might be different. Kathleen, maybe you have a word on that.
In our case, we prefer a customer who want to test our open tool test with PalmSens, because as you can see, we are working on high volume. So for us, distribute low volumes is not something good for us. So if you want to have an open tool 5, the better thing is to order to PalmSens. And as Lutz said, if you want to customize your design, you can contact me. And for that case, the minimum order is 1K unit, but it will depend on the design.
All right, that's a clear one. Very good.
Maybe you can quickly say how to contact you.
So yes, to contact me, you can send me an email or use the contact. You can go to the Linxens Healthcare website, and you have the option of contact, and you can send us.
You can contact us on healthcare@linxens.com.
Very well. Another question for you, Kathleen. Could you give a few examples of products in the market that are currently using this technology?
Good point. Today we are not available to talk about our customer because we don't have the authorization, but we can talk about one product, and this product is Epoch. It's a card for blood gas analysis. It is developed by Siemens Healthineers, and we manufacture millions of pieces for them. So it is the only example that I can promote. And so, yeah.
Maybe there is a question for you both. Sorry, Lutz and Kathleen. Where do you manufacture? Maybe Lutz first.
Sure. So PalmSens potentiostats are assembled in the Netherlands. We have actually our PCB producer we can visit, and we have done so because for electrochemical instruments, it's actually, but you have to be very careful and meticulous about the process. And so the PCBs are mainly produced in the Netherlands, and then the final assembly happens also in the Netherlands. Is our producer still in the region of Utrecht, or?
It's in the Netherlands. In the Netherlands, yeah.
It's in the Netherlands. Okay, good. Yeah.
Great.
And
Kathleen?
yeah, in our case, we have different factories all over the world. So we have a factory in France, specialized in the strip manufacturing, and for stick-to-skin patch, wearable transducer. We are in Sweden, but we have also factory in China.
Then one about the electrodes themselves. So, of course, Linxens produce blank electrodes. Can you also help with functionalization to make them sensitive for a certain biomarker?
So we work with a partner. Linxens produce only the transducer, so the gold electrode or the metal electrodes. So if you want to have something with a biomarker or bioreceptor, we have a partner in UK, and this partner can work with us and can develop this part with us. So you can contact us, and let's see which kind of biosensor you want to do, and we will give the best to produce it for you.
All right, thank you. I'm looking at the time. We'll do one or two more questions. So if anyone is seeing a question they're very interested, please upvote it, and then we'll ask that as well.
I just want to make one comment quickly on the previous question, just to make this clear. So Linxens is only making the PCB technology-based electrodes on the flexible substrate, right? The other electrodes that you saw, they were from third parties that we're not going to name, but the measurements were also made by CSEM, which is a different institute, a research institute, and application-focused research institute is it in France or is it in Switzerland?
In Switzerland.
Yes.
Yeah.
I can see a question. Maybe this one is for you again, both. Can one visit your lab for more research collaboration?
Maybe I just start. So to be clear, we're not doing much research in PalmSens in that sense. We are an electronics and software company. So our research is how to make our measurements better by improving algorithms, hardware, etc. So if you're looking for making biosensors, if you're looking for making electrodes, then PalmSens is not the right place for you. If you are interested in electronics design, in software design, these kind of things, you're welcome to send an application to info@palmsens.com if you want maybe to do an internship or apply for a job. So this is usually what we do. So our labs aren't very impressive, except you're looking for many people doing electronics and software design.
And in our case, we are an industrial partner, so we are not focused on this part of activity. Our strategy is to be the partner of startup and company who want to industrialize the sensors. So we are not on partnership with university and institute for research.
Great.
Perfect. And I think, Sabine, do you still see one more question you would like to answer, or is this it?
I think that's...
So far, we've answered 17 questions, so that's quite a lot.
Yeah, there is maybe last one. Is it possible to obtain samples of electrodes?
It will depend. But contact us or contact Lutz, and we will see in function of the demands if we can send you free of charge electrodes.
Great.
Perfect. Thank you.
Is that it for today? Well, yes. So I would like to thank everyone. Of course, I would like to thank Ardi and Sabine for supporting, the chat and making sure we get all the questions. Of course, a big round of applause for Kathleen, who has educated us all on these type of electrodes. And of course, we thank everyone who has joined today and for all your active contributions. And that was very helpful. Just a small remark. Again, on our own behalf, you will get an exit poll. So you will get the question, how did you like it and what we could do better, or what you really liked, maybe. That's also great to hear. And I think this is it for today. Thank you all very much. Have a great day. Yeah. Bye-bye.
Thank you.